Graphing quadratics in standard form. All right. In a previous video, we talked about the vertex formula. The important thing was that the x value of a vertex is x equals negative b divided by 2a, and the y value of the vertex was plugging the x value of the vertex into the original equation. So that was what we covered in a previous video. We're now going to graph functions of quadratics that are in standard form using this vertex formula. So it's nice when things are in vertex form already. That makes it a lot easier for us. But even if they're not, we can still graph them because we have the vertex formula. So here's our equation, y equals x squared minus 6x plus 5. First things first, does it open up or down? Well, our a value, I can just write all my values right now. Our a value is 1. Our b value is negative 6. And our c value is 5. So a is 1 because there's a secret 1 there. A is 1, which means that it's positive. So it opens up. Positive, which means it opens up because happy people are up all the time. They're happy. Makes this shape here, which means there's going to be a minimum. Forgot if I even put that on there, but it will have a minimum. Opens up. The function has a minimum value. Oh man, don't freeze on me. We're almost done. We're almost done, iPad. You can sleep in a moment. Okay, let's see. Can I just delete you? No. Why? Don't be that way. Okay. X value of vertex. So this is going to be x equals negative b divided by 2a. Negative 6 is positive 6. A is 1. So the x value of the vertex is 3. And to be very clear, what happened here with the 6 is that I did negative 6, which becomes positive 6. So the x coordinate of the vertex is 3. To find the y value of the vertex, I'm plugging this 3 into the original equation here. So y equals 3 squared minus 6 times 3 plus 5. That's going to be 9 minus 18, negative 9 plus 5, negative 4. That's the y value of the vertex. So we have 3, negative 4. There's my vertex. The axis of symmetry goes up and down through the vertex. It's at x equals the x value of the vertex. So the axis of symmetry is at x equals 3. To find the x-intercepts, we are plugging in y equals 0 and solving for x. So let's see. We have y equals x squared minus 6x plus 5. I am replacing y with 0. This thing factors nicely, so I'm just going to factor this one. So this is x minus 5 times x minus 1, factoring this quadratic right here. And using the zero product rule, we're going to get x equal to 5 and x equal to 1. So there are x-intercepts at 1 and 5. I can plot those. For the y-intercept, we're plugging in x equals 0 and solving for y. So our equation is y equals, this will be 0 squared minus 6 times 0 plus 5. That's just 5. So the y-intercept is at 5. Now, it's really great with the axis of symmetry. If I know this point right here is 3 units, I wish it wouldn't draw a weird line there. If I know this is 3 units away, I can go 3 units away on the other side, plot another point, because it's an axis of symmetry. It's symmetric. Okay. Let's, sure, that looks good enough. There's my graph. The domain is going to go from negative infinity to infinity. The range begins at -4, goes up to infinity. The function has a minimum value of, we use the y value as the minimum value, and it occurs at x equals the x value of the vertex. So the minimum value is -4. That's as low as the graph gets, and it occurs at x equals 3. And that is all for this one. Now, I did want to also say that you could use all of this information to take something from standard form and put it into vertex form. So if I know that the A value is, what was it, 1, I know that the vertex is at 3, -4, so h is 3, k is -4. I can plug this into my vertex form, and then it would be in vertex form. So if you ever are trying to go from standard form into vertex form, you already have the A value that just comes with the product, right? A is given to you. To find the H and the K, you use the vertex formula, and then bam, you have it in vertex form. So that's pretty cool. Anyway, that's how this works. If you have questions, please let me know. Otherwise, I hope you have fun graphing quadratics. I'll see you in another video. Bye.